Have you ever wondered how the axles that carry tons of weight in a vehicle are made? Behind every axle is a high-precision engineering process where even the smallest error can put the safety of an entire car at risk. In this video, I'll take you step by step through how these essential components are created, from raw steel to the finished axle ready to hit the road. Get ready, because what you're about to see isn't just manufacturing, it's industrial precision at its finest. It all starts with a material, steel. But not just any steel. Special alloys of chromium, molybdenum, or manganese steel are used to manufacture axles, selected for their resistance to torsion, tensile strength, and fatigue. The steel arrives in large bars or billets, which are stored under controlled conditions. Before entering the production process, each batch undergoes chemical analysis in a laboratory, where its exact composition is verified. Only batches that meet customer specifications and international standards continue in the process. Once approved, the steel moves to the cutting area, where automatic saws segment it into more manageable pieces, known as preforms. Each preform has a specific length and diameter, depending on the design of the axle to be produced. With the preforms ready, the thermal transformation begins. The pieces are automatically transported to a heating furnace that exceeds 1,100 degrees Celsius. Under these conditions, the steel becomes malleable enough to be forged without breaking. The next step is one of the most impressive: hot forging. The incandescent pieces are placed in giant hydraulic presses or forging hammers, which apply thousands of tons of pressure to give the shaft its basic shape. This process, in addition to molding the part, improves its internal properties, aligning the metal's grain structure and increasing its strength. At this stage, thicker or reinforced areas are defined, such as the ends where bearings or gears will be mounted. The result is not yet a final shaft, but rather a robust part with a defined overall geometry. Once forged, the shaft undergoes controlled cooling, and then the next step, intermediate heat treatment. After forging, steel still retains internal stresses generated by hot deformation. To stabilize the material structure, it undergoes a thermal process called normalizing, where it is heated again to a lower temperature and then slowly cooled. This relieves stresses, uniforms internal hardness, and improves machinability, making subsequent cutting and machining easier. In many cases, tempering is also applied, a gentle hardening process that reduces the brittleness of the part. This step is essential to prevent deformation in subsequent stages, improve dimensional accuracy, and ensure a solid foundation for the quality of the final product. Once the axle is stabilized, one of the most critical stages begins: machining. The parts pass through a line of high-precision CNC machines, where all the necessary surfaces are turned, milled, and drilled. Here, exact lengths, external and internal diameters, tapered shapes, ring grooves, and contact surfaces are defined. Depending on the design, some axles require machining of splined ends, surfaces with micron tolerances, or even housings for electronic sensors such as ABS. These operations are performed in manufacturing cells where automation and robotic arms ensure repeatability and speed. Each part is inspected in line by sensors and electronic measurements. If any exceeds the established parameters, it is automatically removed from the flow for review. At this stage, the axle already has its final shape, but it still needs real strength to withstand the work it will do in the vehicle. Therefore, we move on to the final heat treatment. Once the axle is heat treated, it moves on to high precision grinding. This stage polishes key surfaces to ensure perfect fits at the contact points: bearings, gears, retainers, and suspension components. A surface treatment is then applied, such as bluing, phosphate coating, galvanizing, or anti-corrosion coating, depending on the type of vehicle and the environment in which the axle will operate. This ensures that the part resists moisture, dirt, salt, and other external factors that could deteriorate it over time. Finally, the batch number, manufacturing date, and traceability code are engraved, sometimes with a laser. This allows the complete history of each axle to be tracked, from the steel to its final delivery. Nothing is left to chance here. Each batch of axles undergoes a strict quality control process, including destructive and non-destructive testing. Three-dimensional coordinate measurements, ultrasound, and industrial radiography are used to detect possible internal cracks, as well as hardness, tensile, bending, and torsion tests. Some axles undergo lifespan testing on test benches that simulate millions of cycles of use. Everything is digitally recorded. Only axles that successfully pass each test continue to assembly. Those that fail are discarded or reprocessed, depending on the type of failure. In this type of industry, there is no room for error. The parts that have passed all inspections are sent to the assembly area. There, additional components such as flanges, bearings, seals, caps, and even electronic sensors that send information to the vehicle system are installed. Everything is adjusted with calibrated tools, following protocols for tightening torque, torque control, and assembly order. Once assembled, the axles are inspected again for looseness, misalignment, or functional failures. While you enjoy the content, remember to subscribe to the channel for more videos about machinery and engineering. And so concludes this complete tour of the automotive axle manufacturing process. From raw steel to the final part, what you've just seen is the result of technology, precision engineering, and strict quality control that ensures each component operates safely on the road. If you enjoyed this video and want to continue exploring the fascinating world of industry, technology, and manufacturing step by step, subscribe to the channel and click the bell so you don't miss any upcoming content. Here, you'll discover how the things we use every day are built, from inside the world's most impressive factories. Thank you for joining us. See you in the next video.